Hi, my name is Anna Slominski, and today I will be talking about the effectiveness of different capping materials on slowing the migration of PFAS chemicals through sediments and into water. I'd also like to state that this research is funded by the EPA's P3 program, so we would like to thank them for their support. The chemical researched in this study is called PFAS. It's a class of synthetic compounds made when fluorine atoms are attached to an alkyne chain. The compound was first developed in the mid-20th century by manufacturers specifically in the Appalachian region, which makes those communities particularly vulnerable. The compound has properties of high heat and water resistance, making it perfect for household products such as nonstick pans, food packaging, and fire-resistant clothing and tools for firefighters. Because the chemical was, and honestly still is, used in a wide variety of products, it is moved into the ecosystems. And because of this, PFAS has been able to bioaccumulate, as nature has a really hard time filtering it and an even more difficult time destroying it. This results in many negative health effects on both humans and wildlife. These can be birth defects such as low birth weight and increased risk of cancer and autoimmune diseases. Communities where PFAS is at a higher concentration tend to see these diseases at a higher rate, which, as these communities are normally already low income, it makes them even more vulnerable and even harder hit. As the chemical has such negative health effects on the environment and on the people, different mitigation options have been developed to stop exposure, such as dredging, monitored attenuation, and what I'm focusing on today, which is capping. Capping involves putting a layer of eco-friendly sorbent material as well as a layer of sand to slow the migration of PFAS into the water. The materials that we've used in the study are activated carbon, ion exchange resins, and argon clay. All of these materials are extremely sorbent and attract the PFAS chemical so that they won't move through the cap. The main goals of this study are in Figure 2, and they're to examine the effectiveness of capping materials in slowing PFAS, develop analytical methods of determining concentrations of PFAS in the sediment and in the water, characterizing PFAS transport through modeling using software, and to assess the effectiveness in conjunction with the costs to find the best solution. The methods of the study follow along with the goals. So first, we've been building a tank, as you can see in Figure 4. It's made of plexiglass. It's 100 centimeters across and then 60 centimeters in height. The bottom of the tank is where we will put the spiked sediments to then on top of that have the thin layer of capping material, on top of that have a layer of sand, and then finally have the water on top that's going to be pumped to simulate a river system. The peeper, which you can see in Figure 3, we will have many different copies of it, which will then be placed all in the tank at different spots. The peepers will work by having 10 milliliter ports, which are spaced out every 2 milliliters, which to separate the ports from the sediments so that the sediments don't get into the ports, there's a thin membrane that only allows small molecules, including PFAS, to travel through. Then each peeper will be taken out at different intervals throughout the study so that we have concentrations of PFAS in the sediments and in the water at different points. These samples of the contaminated water from the peepers will then be assessed at the Institute for Food Safety and Health using an LC-MS machine, which is a mass spectrometer to find the concentrations of PFAS in those samples. From the data of the concentrations of the samples at the different intervals of the study, the data will be used to model the transport of the PFAS chemical using previously developed software called CapSim, which will be able to predict how the caps will perform in nature. This is done by assuming concentrations of PFAS in the water is 0 at time 0, and then using different concentrations in the water at different times in the study, model how the chemical will move in real time. Finally, the effectiveness of this material and the cost of the material, we will determine the best option. The reason for this research and the future impact of it is not only to help high-risk communities, but to help everyone in the US and the world as whole. PFAS can actually be found in 99% of Americans' blood, so it's safe to say the effects of this chemical are not going away anytime soon. There are two sides to the positive effects of using these capping materials to help. One is the obvious environmental impact of slowing the exposure and trying to decrease the chance of cancer and birth defects. It is also just trying to stop this particular type of pollution in both air and water, as the same effects that are happening on humans are also happening in wildlife. This research also helps economically, as many local, state, and federal governments are spending large amounts of money on monitoring this chemical, and this capping method may be able to provide relief from this needed monitoring. In conjunction with the environmental effect of slowing the negative health effects, it also helps economically, as then less people will have to pay for the health care that was caused by the exposure to the PFAS. So this capping method not only helps the government spend less, but individual citizens. Finally, one of the most important parts of the future plan, what do we do with this data so that it can help people and be implemented in the correct way? First, it will be presented at the National Student Design Expo, which was supposed to be in Austin, Texas before coronavirus. This is where a second grant can be awarded for this research to be expanded on, which we will then use different types of PFAS and also different capping materials. We're also working with a team of business majors at IIT to develop a business plan for the capping material found to be the best. That is an overview of this research, and thank you for listening.